Okay, everybody, this is chapter 9, section 5, and I got to do this kind of quick. I'm sorry about that. This is a congruence of transformations. So this is like doing a couple different transformation rules at the same time, okay? So in this chapter so far, we've done translations, which is use capital T to signify that, and then we use R as reflection for that one, and then we have rotations, and we rotate stuff 90 degrees, 180, and 270. Okay. So we need to be able to use a combination of these things to move stuff around on a graph. Okay. This little definition here is just saying, hey, if you want to keep things congruent, two figures, then you can do a couple different things to move it around the graph. Okay. So I kind of already did this in this particular one. You're looking at moving the parallelogram from one to the other. Now, I kind of take exception to this one because it doesn't tell me which one to map it onto, which way to go. And so it's kind of nice to know that. Okay, so we started with the parallelogram, and they're not telling me which way to go. So we just in class today, we decided that we were going to move. A, D, B, C to H, I, J, K. Okay, and when they're talking about a sequence of rigid motions, that means I got to do more than one movement. So that means like a translation and a reflection, or a rotation and a translation, whatever. But when I'm looking at this, it looks like I could just translate this one straight there. Okay. So, but since they told me I have to do a sequence, what I did was I moved it sideways. I moved it with a translation. I moved it 6 in the positive X direction, and I didn't move it up or down. So that's why Y is 0. And then I mapped it. And then from where I mapped it, I moved it just straight down. And so I didn't move it left or right. So that's why X is 0. But then I moved it down 5. Okay. So to me, that I followed the rules. I did a sequence, but to me, I should be able just to do one translation rule. Okay. All right. So that's what we did. So then we looked at the triangles, and what we kind of decided was that we did these rules here. We translated it over 6. So this U went to right here. And then V, we moved it over in negative direction 6 again. So it got me here.
Zane Heyman, report to the front office. Zane Heyman, report to the front office.
And we took W and did it again, moved it 6 in the negative direction. So I ended up getting my triangle to be right here. Okay. But I have to get it here. So we kind of had decided to go in this direction. So we realized that, hey, you can just flop this over the x-axis. So that's a reflection. Okay. Now, last section, we learned that when we write the rule, the first movement has to go second, and the last movement goes first. Okay. So that's why this is listed first, and then this is listed second. Okay. Okay, so we did the translation first, but we got to write it second. We did the reflect across the x-axis. We did it last, but we write it first. Okay, so then we come down to here, and what we had here is that we had to be able to reflect. And this one, they actually gave me a pretty clear idea of where I go, what I needed to do. Okay, so they tell me, hey, go ahead and map NAV onto BCY. So we're going to go in that direction. So one of the things too we did really quick here today was there's more than one right answer for these. And since I have 3 different options, I can reflect it, translate it, rotate it. Sometimes what you think you might be able to do doesn't really work. And so that's going to get kind of tricky. The one thing we did kind of talk about is that since they gave us letters, they told us where to map it, we got to make sure that corresponding points land on each other. So we kind of picked V and Y need to land on each other, okay? So what happened was that some of us decided that, hey, you could probably move V over to here. That gave me a translation of -5. So if I moved all of these over -5, I get to here. And we just sketched it, so it's a good thing you have this in a, do it on graph paper and do it in pencil. I got it there, and looking at that, it looks like that I can take this and I can just reflect it across the x-axis again. So this point does map onto this. This point, distance-wise, it was 4 away, so I go 4 away, I land there. This is 3 away, so I'll go 3 on the other side. It lands there. So I get that, and all the points match up to their corresponding points. So that's, again, a reflection across the x-axis. So we translate it first, so I write it second. I reflected it last, but I write it first. Okay. So that's kind of what we did today for 9.5. Pretty straightforward. It's kind of a short one, but really important that you practice this, because like we did a translation and reflection of both of them. It doesn't always happen that way. You might want to be thinking about these rotations. We also kind of did a little review on the rotation stuff, how to change your X and Y values depending on the angle measure that you're going to rotate. Okay, so hopefully you did good on that. If you need help, please make sure you get a hold of me.